We got my favorite topic tonight. It goes in with also the evolution topic as well, because they're actually really related, and that is the complexity of life, and really the origins of life. That's mostly what we're going to be talking about tonight, is the origins of life. And I have no idea why that slide did that, but like I said, tonight we're going to be talking about the origin and complexity of life, and then I think what we'll do to wrap up the teleological argument is talk about the evolution versus creationism debate the next session that we do. But we're going to be talking about the origins of life. And again, just for review, these are theistic arguments, or arguments for the existence of God, because we're going through a two-step apologetics. First, you prove that God exists, then you prove that the Christian God is the right one. And as we've talked about, we're talking about the argument from design, or teleological argument. This, as we've talked about many times now, is an inference to the best explanation. It is not a deductive argument where if 1 and 2 are correct and follow, then you absolutely have 3. But as you will see from some of the things that we'll talk about tonight, and from some of the things that we've talked about in the last couple sessions, it is really hard to deny the amount and the enormous complexity of this universe, of this planet, of life itself, and of the information of life. And so we talk about the fact that much of the ways we're going to look at all of these things is an argument from analogy. So just like a watch has a watchmaker, because it exhibits order and function and design, when you look at the order and function and design in tonight's case in life, you will see that in an analogous manner, life needs a life giver. Life needs an originator, a creator. And the fine-tuning arguments itself is in a way a deductive argument, because if each of these premises follows, then you get the conclusion. And of course it starts with the fine-tuning as a result of necessity, chance, or design. That's the only 3 options. There are no other options there, right? I mean, I consider myself a relatively smart fella. I can't figure out a 4th option there. And so we're going to say that they're not the result of chance or necessity. Therefore, they're the result of design. And if you have design, you have to have a designer. That just simply follows. And first, we talked about the complexity of the universe. And last week, we talked about the privileged planet. So now we're going to talk about the complexity of life. And in Genesis 1:11, it says, "And God said, let the earth bring forth grass, the herb yielding seed, and the fruit tree yielding fruit after his kind, whose seed is in itself upon the earth. And it was so." So that was the first of the creation of life in Genesis 1:11. So the real question is, what is life? It seems like a dumb question. What is life? Well, I mean, we know what has life, but what is life? It's a hard question to answer, actually. If you stop and think about it, what defines life? Well, believe it or not, there aren't that many great definitions out there. But kind of the simplest way of looking at it is, for something to have life, it has to have certain compounds. It has to be capable of certain things. Number 1, it has to be able to get some sort of nutrients. Whether you're talking about the simplest amoeba or one-cell organism, bacteria, or whatever, it has to have the ability to get nutrients. It has to have some way to metabolize those nutrients. It has to have some form of respiration. Now, it doesn't have to have our kind of respiration, right? Plants have a different type of respiration than we do. Again, you look at the amazing complexity of the life on Earth. Plants use carbon dioxide, they generate oxygen. We use oxygen and generate carbon dioxide. Pretty amazing how those things come together. And they have to be able to reproduce. This is why I wouldn't, and most scientists would not consider viruses to be alive. Now, no doubt that they contain some of the same components that things with life have, but guess what? They can't get nutrients. They can't metabolize them. They have no form of respiration, and they can't reproduce themselves. We have to. The host has to reproduce a virus, whether it's a bat virus and the bat that's reproducing the virus for them. The reality is you can get one single viral particle. That's why they're called viral particles, by the way. You can get one single viral particle, and then your body is going to reproduce thousands or millions of copies of it. But they don't actually reproduce themselves. That's why viruses aren't considered life. And they have to be able to respond to external stimuli in some form or fashion. Okay? Now, does it all look like human life? No, of course not. That's ridiculous, right? Now, that's weird. I don't know why the slide did that. Additionally, life, there are certain compounds that are absolutely required for life. And in today's day and age, we consider a lot of these as if they're simple compounds. They're not, okay? In order for you to produce something that has life, you have to have available carbohydrates, you have to have available lipids, fat, right? You have to have available ribose sugars. Remember, ribose sugars are the things that they're the linkage portions of DNA, whether that's RNA or DNA. And you have to have amino acids to build proteins. You don't have those, you don't have life. Period. Now, sugar seems like a simple compound, right? Wrong. Try to build one.
Build sugar.
Go ahead. I'll give you all the carbon, hydrogen, oxygen, sulfur you want. Go ahead and build a carbohydrate by yourself with no manual. No manual. Okay? No lab notebook, no manual. Try to build a carbohydrate. I dare you. Okay? These are not easy things. In 2021, we think of them as being easy because, we can just look at the net carbs on a label. Well, that doesn't mean it's a simple process, okay? You got to understand that in the time of Darwin, that is what a cell was. That was the building block of life. It was a blob. It was protoplasm. That's it. They had no idea. There was no such thing as an organelle. Everybody know what an organelle is? No. It's the little pieces, parts inside of the cell that do the different things. Like the nucleus has the DNA, right? The ribosomes are the things that build the proteins. You have transmembrane proteins, they call them. So in other words, once you get the proteins, how do you get it out into the rest of the body? Well, it has to go through the membrane. So every one of those little pieces, parts inside of a cell is called an organelle. They had no idea any of that existed. None. They knew cells existed, but when Darwin talks about adaptation of cells and life, that's what he thought it was, just a blue blob. Or green or yellow or whatever. I don't know what color he thought it was, but it was just a simple bag of protoplasm. Like taking a balloon, filling it with water, and that's a cell. That's what they thought it was. They had no concept of the complexity of what life really is. Remember, DNA hadn't been discovered by then, right? Microscopes that could look at the electron level of a cell hadn't been invented. They had no idea. So this is what Darwin and the people of his day thought life was. Well, it turns out it's a heck of a lot more complex than that. So let's talk about the origins of life, okay? With the origins of life, you will oftentimes hear the term abiogenesis, right? Anytime you have a before a word, it means lack of or not, right? Like atheist, someone who does not believe in a God. Abiogenesis means there was no biology, so this is the stuff before then. In other words, life from non-life, okay? They oftentimes say from the goo to you via the zoo, okay? So in other words, what it's looking at is what we will call pre-biotic Earth. And by the way, pre-biotic Earth exists in Genesis chapter 1, verse 1. In the beginning, God created the heavens and the earth was without form and void. I just read to you Genesis 1:11, where God began the creation of life. But there was a time before that, right? So we're talking about the pre-biotic earth. Now, like I said, in the beginning, God created the heavens and the earth. The earth was without form and void, and darkness was over the face of the deep, and the Spirit of God was hovering over the face of the waters. This is where we're talking right now, okay? Remember, life came on what day in Genesis? 1, 2, 3, 4, 5, or 6? Nope. Life, the first life. Genesis 1:11 was on day 3. Day 3. Life came on day 3, okay? So, this is the time frame I want you to take your mind back to, okay? Before any life existed. Because whether you're a believer in God and Jesus Christ, or you're a complete atheist, you believe that there's a time before life existed on this planet. Right? Right, Pastor? There you go. Okay. Now, in those times, understand there was no life. So what did you have? You had pure chemistry. Doesn't matter what was there, but the reality is the only thing that was there was just chemicals. No biology. No life. Here's the problem. Chemical compounds don't care about life. They don't care about life. Not only do they not care about life, if they don't care about life, how do they move toward life? They don't know what it is. How do they know what they're going to? If you don't have a goal in where you're going, you ain't ever going to get there. And that's what we're going to talk about tonight, is how ridiculous that concept is. It is mind-boggling how ridiculous the concept of life from not life is. Dr. James Tour, he's a synthetic organic chemist. He's a nanoscientist. This guy has built nanomachines, organic nanomachines that can roll along the surface of different compounds and do things like deliver medications into cells. His work has resulted in like 8 or 9 different companies. This guy's amazingly brilliant, and he is a God-fearing, Jesus-believing Bible freak, and I love it. And he says, molecules do not care about life. Nobody has ever seen molecules assemble towards life. Molecules do not move toward life. And I agree with him. You see, again, when we're talking about the prebiotic earth, we're just talking about random compounds that were around. Now, there was water, sure, okay? There was probably nitrogen. Why do we know that? There's nitrogen in our atmosphere, oxygen, carbon dioxide, things of that sort. But let me ask you this. If I gave you all the pure carbon, all the pure sulfur, all the pure oxygen, all the pure hydrogen, and all the pure nitrogen that you wanted, could you make a single one of those compounds? Evolutionists will tell us that we are the pinnacle of evolution, right? We have the most intelligence of anything there is. But yet, I guarantee you, and you are smart people, I know y'all, I could give you all of those things, you're not going to make a single compound out of them. How do I know that? Because I spent 4 years learning how to make things out of those types of stuff. Don't forget, I was an organometallic chemist in college. That's what my undergraduate thesis was in. We'll talk about some of the things I used to do to try to make one compound. 10 months I spent trying to make one compound. So no matter how much I give you, I could give you all of that. You're never going to get one of these. This is what an amino acid looks like in its simplest kind of just, these are the 3 parts of an amino acid. Okay? The simplest amino acid is this one, glycine. Looks relatively simple, right? Okay, what if I gave you all those compounds I just talked about? Could you make a single one of these in a lab? No, you could not. No, you could not. Especially if I didn't give you a lab notebook on how to do it. Guess what? In the prebiotic earth, there was no lab manual. And there was nobody cooking the chemicals together other than God to bring forth these compounds. Those are the amino acids that we use for life. There's 20 of them. Did you realize there's actually 400 different amino acids, but we only use 20 of them in life? Not only that, do you realize that when it comes to compounds like this come handed. They call it chirality. They're mirror images, okay? So when the compounds are being made, if they're just being made in kind of a natural environment, they come in both, left and right-handed, right? We stop and think about it. Left and right-handed, they are mirror images, but you can't superimpose them. That's why you can't put a left-handed glove on a right hand and vice versa. Okay? So, when we talk about compounds in life, almost all of them are homochiral, only one way. Okay? So you can't take a left-handed and put it into a right-handed spot and make it work. When you talk about amino acids, you have to have them all homochiral. They have to all be the same. And they all have to link together the same. Now, not only that, if you look at that one up in the upper left, that's glycine. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 atoms on it. That's it. That's the simplest amino acid. Okay? Now, if you look at the different ways, theoretically, that glycine could lead to another glycine, to another glycine, to another glycine, there's 9 spots, so it's 9 times 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 9. That's how many different ways those can link together. Now, I'm not great at math, but that's a really big number. 9 to the 9th power, really, really, really large number. But guess what? If you link glycine to glycine in any other way except the exact way it has to be hooked together, it doesn't work. And it's that way for all of those amino acids. You can't build a functional protein by randomly sticking those things together. They have to be stuck together in exactly the right order, in exactly the right pattern to have a functional protein. A lot of atheists will point back to something called the Miller Urey experiment and say, oh yeah, we've done this before. Yeah, we've made life. Okay, here's what happened in the Miller Urey experiment in 1952. These two guys were organic chemists, and they put a bunch of stuff into a flask, put a lot of heat to it, and then hit it with electricity. And lo and behold, they got some glycine out. Now, here's the problem with that experiment. Number one, the stuff that they were using to put all that together, they were all compounds that were pure, that were bought from a lab distribution center. It was in a lab. It was being performed by intelligent people. Okay? And studies have now shown that the stuff that they put in there isn't what was in the pre-biotic earth anyway. But they hit it with electricity. And all they got out was glycine. Just glycine. And people said, aha! We've made the building blocks of life. No, you haven't. You made one. And guess what? Since 1952, we are no closer in a lab to coming up with the origin of life or with life itself than we were at that time. It's garbage. It's absolute garbage. Because even if they came up with all the amino acids, guess what? They're still missing the carbohydrates, they're missing the lipids, they're missing the ribose sugars, and nobody knows how to put it all together. I could give you all the lipids, all the carbohydrates, all the ribose sugars, and all the amino acids that you want, and I dare you to put together life. You can't do it. Nobody knows how to do it. See, what they didn't understand, and what most people don't understand, is it's not just a matter of doing things like linking proteins together. Proteins then have to fold. So when they first come out, they're made in just a chain link. Looks like literally like a linked chain. But they're not functional then. They start getting folded, and then folded a little more, and then folded a little more, and folded a little more. And finally, they reach a structure that looks like this, called a quaternary structure. Guess what? Has zero function until it gets to that. And if you mess up one amino acid in that chain, it's done. Doesn't work. Smallest functional protein that we know of, 150 amino acids long. 150 amino acids long. That can't happen on its own. It just simply doesn't. No one's ever observed it. And even if they observed it in a laboratory, guess what? You haven't shown abiogenesis. Why? Because it took an intelligent designer to do that. Right? You've not disproven God if I give you a bunch of pure compounds and you come up with a functional protein. Because that's still an intelligent design. You still don't get around the problem of a designer if you're an atheist. It makes no sense. Their own science works against them. I want you guys to watch this short video.
When applied to the origin of life and the random formation of large biomolecules, probability theory clarifies the limitations of chance as a creative agent on the primordial Earth. For example, what are the odds a single protein could form exclusively through the blind interactions of chemistry? Our target is one smaller than average molecule made from 150 amino acids, each aligned to ensure a folded chain. Researchers have calculated that on the ancient Earth, the probability of success was 1 chance in 10 to the 164th power. That's one correctly sequenced protein chain for every 100 million trillion 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 failed attempts. But despite these enormous odds, some theorists argue that given enough time, anything is possible. Okay, let's test the validity of this opinion. We'll begin by establishing an ideal environment for chemical evolution, an imaginary world that will provide chance with every opportunity to succeed. First, we stock the oceans to capacity with amino acids. That means all the atoms on Earth, including its entire supply of carbon, nitrogen, oxygen, hydrogen, and sulfur, are available to form 10 to the 41st complete sets of the 20 types of amino acids used to build proteins. Then we'll alter the laws of nature to protect these building blocks from the destructive rays of ultraviolet light and chemical contamination in the primordial soup. Now let's turn the chemistry loose and see what happens. The amino acids start bonding furiously. In our experiment, an entire chain of 150 units self-assembles in only 1 second. Since all 20 types of amino acids are available, at the majority of sites, there is a 5% or 1 in 20 chance the correct molecule will align in the chain. If the sequencing is incorrect, the chain is immediately destroyed and a new assembly begins. Throughout the planet, 6,000 million billion trillion trillion attempts will take place every minute. That means in 4.6 billion years, the oldest estimated age of the Earth, the number of chains that don't fold will exceed 10 to the 58th power. It's a staggering total, but nowhere near 10 to the 164th. The trials necessary, on average, to build a protein of 150 amino acids by chance. So if undirected chemistry can't produce our coveted molecule during the entire history of the Earth, then how much time would have been needed? To find out, let's take a road trip. We'll start by erecting a bridge that spans the diameter of the observable universe, a distance of more than 90 billion light years. Then we'll place an amoeba on one end of the bridge. This single-celled organism will travel at the breakneck speed of 1 foot per year. It's off. While we wait for one protein to form by chance, the amoeba slides along for more than 5 billion years to cross the entire universe and then return. But this race is just getting started. The amoeba takes off again, successfully reaches the far side of the cosmos, then heads back home. Yet not even one functional protein is anywhere in sight. For the next trip, we'll add a payload, a single atom. After inching its way another 500 billion trillion miles, the amoeba drops off its cargo and returns for more. Will it get back before our lucky protein forms? Absolutely. In fact, it will complete another 10 round trips, then 20, 100, 1,000. And there's still no sign of a usable molecule. The amoeba continues making round trips until it has hauled off every atom on Earth. Then, all of the atoms in our solar system. Then, every planet and star in the Milky Way galaxy, one atom at a time. In fact, as we wait for one protein to self-assemble, the amoeba has so much time that moving at just 1 foot a year and carrying 1 atom per round trip, it will transport the entire universe more than 56 million times. That's how long it would take for chance to build one functional protein.
Now, suppose against all odds, chemical evolution produced our single functional protein. Would we have life? No. We'd have one protein, just a lifeless arrangement of amino acids. The simplest living cell we know has more than 300 different proteins. But proteins are only part of the story when you consider any actual cell. Remember, you're going to have carbohydrates, complex sugars, nucleic acids, DNA and RNA, lipids, a whole variety of different chemicals which jointly constitute the living state. Those bits and pieces all have to be brought into the same microenvironment at the same moment in time.
Each chemical building block must then be assembled and organized into the network of molecular machines that will control every facet of life.
If we can appreciate exactly how hard it is to produce one molecular machine using nothing except atoms and energy, we can see that there's a profound problem, because once you have one molecular machine, you don't have a living thing. These molecular machines need other molecular machines. And even if nature was capable of producing all the molecular machines necessary, that still wouldn't be enough. They have to all be together, all in this tiny little membrane-bound space that we call a cell.
From my understanding of what it takes to make a cell, it has to happen all at once. You can't do it one bit at a time. because everything works together in a causal loop. The higher level of organization transcends the pieces. The spatial organization in the cell requires that molecules end up in the right place at the right time. The DNA is copied into RNA. The polymerase that does the copying has to find the right spot in the DNA to start copying. The RNA has to somehow hook up with ribosomes, which have to be in a particular place. And the proteins then that are made have to be going to a particular place. That's an awful lot to account for by random chance.
The probability that you would get them in the same space at the same time becomes beyond unimaginable. And the probability that you would get them within a membrane enclosure, like a cell, is the next best thing to impossible.
So do you understand the implications of that? You can't even get one functional protein by chance. And what they were saying at the end is, even if you did, you still don't have any of the other parts of a life, of a living cell. And even if you did, they're not together. They have to be inside a cell to make life. Because remember, what does life require? It requires the ability to get nutrients, to metabolize those, to have respiration, to respond to the surrounding environment, to reproduce. None of those things have you gotten yet. In all that time where they're talking about that amoeba taking an atom at a time, think about that, an atom at a time across the universe, the known universe, at 1 foot per year. So what they're saying is this: if you took all the carbon in the universe, put it on the face of the earth, allowed it to chemically react at the most rapid rate possible, and left it for 1 billion years, the odds of creating just one functional protein molecule would be 1 chance in 10 to the 60 zeros after it. That's that many. So what they're also saying in this is, again, even if I gave you DNA, I'll be more generous to you. I'll give you DNA. I'll give you RNA, I'll give you proteins, I'll give you lipids, I'll give you all of this stuff. Voila, you have life, right? No. Because nobody knows how to put any of that together. With all of the technology that we have, with all of the labs that we have, having kept journal and journal and journal and journal, nobody knows how to do that. We know what the lipids are. We know what the proteins are. We know what DNA is. We've got the entire human genome sequenced. Nobody can put it together. Not a single cell. Never. We're no closer than they were in 1952 when Miller and Urey did their experiment. No closer at all. When you look at the simplest of bacterial cells, the mycoplasma, doesn't even have a nucleus. It just has free-floating DNA in it. It's got some soluble RNA, some ribosomes. For those of you who don't know what that is, that's part of what you need in order to build a protein. So it's what hooks on and reads the code to get the right amino acid there. You've got the 3-layer cell membrane. You've got soluble proteins floating in there. I could give you every one of those compounds, and I dare you to make that. You can't. Because even the cell membrane is not just a membrane. They actually look like this. They've got all these protein channels. They've got lipid bilayers in there. They've got glycolipids that are cell signaling from one to the next. Do you realize that the cell signaling inside of a cell happens at the speed of light? These are called interactomes. They're protein-to-protein networks. They work so fast. They work faster even than neurons firing from our brain to our legs. They literally work at the speed of light. And there's somewhere around, like, it's like 10 to the 69 billionth power. That's how many are in each cell. No one knows how that happens. There are things called microtubules. That's how you get protein from one area to the next. The cell is so complex that when it builds a protein, It doesn't build it where it needs to be. It's like us, right? We don't build the materials on site when we're building a building. We built the material somewhere else, we transport them. The microtubules are the 18-wheelers. The cell is so complex, it builds a new microtubule, transports the protein to where it needs to go, and then breaks down and reassembles somewhere else. We have no idea how that happens. None. Michael Behe, who is a brilliant microbiologist, said, in private, many scientists admit that science has no explanation for the beginning of life. Darwin never imagined the exquisitely profound complexity that exists even at the most basic life level. Let me explain to you, I'm going to give you an example of what organic chemistry is like. Okay, synthetic organic chemistry is like. My lab, where I worked in college, had made a complex called fipronil. Technically, it was polyfipronil. It basically took a ring of nitrogen and carbons, plugged them onto an iron molecule, and then made a polymer out of it. Well, this polymer actually has some pretty incredible properties. Semiconducting, it actually has some military uses where it can be used as like a coating to keep it from being picked up by radar and certain other things. And so what my lab was doing at the time under my mentor was we were trying to do the same stuff, but with different metals. Because, you know, if you change out iron for, say, nickel or platinum or palladium, which were the three that we were looking at, and I was doing the nickel ones, then maybe it changes the property of the polymer, right? Maybe it's more semiconducting. Maybe it does better at, you know, keeping radar from seeing it or whatever it is. Let me explain to you what my day was like. Now, I had a manual. I had hundreds of articles I had read on how people built similar polymers in the past, okay? Every day I would come into work for 10 months. 10 months. Nickel is very, very sensitive to water and oxygen, like many compounds, right? I would come into work, I'd get all of my flasks. I would wash them out with acetone, fingernail polish remover, okay? Which evaporates very quickly, right? To get all the water out. Then I would put it in a drying oven at several hundred degrees to get all the rest of the water out. Then I would very rapidly, with very thick gloves, take it over to our glove box. Because all of these experiments need to be done with no oxygen and no water. So I'd put them in the port. If you've ever seen a glove box, works a lot like the side port of a glove box works a lot like a submarine, okay? Where, you know, it's got the two doors, right? You can pump the water out or you can pump the water in. People can get in and out. Same thing here. So I would put all my stuff in there, including all the compounds I needed, right? Boom, put them all in there, sealed up. And I would evacuate all the air and fill it with nitrogen. And then I'd evacuate all that and fill it with nitrogen again. And then I'd evacuate all that and I'd fill it with nitrogen again. And then I would go into the gloves, open the inside door, bring all my stuff in. God help me if I ever forgot something, because I had to go through that entire process once again. Now, while I was there, I'm reading manuals and doing things so precisely you can't even imagine. It had to be, certain things had to be heated to within 1 or 2 degrees. And then they'd have to be cooled. And then they'd have to be mixed this way with this amount of this and this amount of that. All the while, I'm writing all of my steps down. Because guess what happens? If you don't do it for the right length of time or at the right temperature or any of those kinds of things, guess what happens to those products? They break down. None of the stuff I've even talked about talks about the breakdown of any of this. Remember how the video talked about preserving those compounds from UV radiation and oxygen? Guess what UV radiation and oxygen does to almost any of the compounds that are required for life? Breaks them down. Here's the problem with chance. Even if you made one, how are you going to preserve it? Oxygen breaks it down. Well, you better have oxygen for life, right? Water breaks a lot of them down. You better have water for life. You got to have heat and light. Guess what breaks down most of those compounds? Heat and light. How do you denature a protein? You heat it. We got to have the sun. We just talked last week about how you have to have the sun where the sun is in order to have our planet. Okay? So back to the glove box. I go in, I do all these experiments all day. You want to know how many times I actually got the polymer made? With manuals telling me how to make it. Take a wild guess. Once. And I could never repeat it. I tried for months to repeat it. I never could. I had manuals on how to do it. I had notes on how I had done it. Couldn't ever repeat my work. And to my knowledge, I don't think anyone ever has again. Probably because they realized it was too stinking hard. But the point is even with all of that, with people's work before me, I couldn't make an organic polymer. That's how complex all of this is. And here's the deal. They touched on it a little bit in this video, but I want to bring this point home. Let's take life out of it for a second. What if I gave you a box the size of this area we're working in right now, with every single piece of a functioning Mercedes-Benz? Do you have a Mercedes-Benz? I'm going to argue that you don't. Because what I consider a Mercedes-Benz is something I can open the door, hop in, turn a key, and it takes me from point A to point B. If I gave you a box with all those parts, do you have a functioning Mercedes-Benz? No, you do not. Even if I gave you all the parts in the box. I would argue, because I'm not a motorhead, that even if you gave me the instruction manual on how to put that sucker together, I probably can't do it. Life is infinitely more complex than the parts of that Mercedes-Benz. Now, what atheists are trying to convince us of is not only that all that math we looked at doesn't matter, because the atheist mantra is give it enough time and chance and it might happen. Even if you took all the time in the world, here's the deal. You still have to have it all together. So now, take that complex Mercedes-Benz and all the pieces, scatter all the pieces across the entire known planet, and now assemble it and try to tell me it's a Mercedes-Benz. Good luck. Life is infinitely more complex than that. So somehow an atheist wants me to take the leap of faith, and that's the only way they can do it. They want me and you to take the leap of faith that not only did all those compounds get made by chance and time, but they were all constructed in the same place at the same time, somehow shoved in a cell, and voila, it all happened. That's garbage. I'm going to call it like it is. That is garbage. And as Frank Turek says, as the title of his book, if that's what it takes, if that's the faith it takes to be an atheist, I don't have enough faith to be an atheist. It's garbage. So Tour says nothing's changed in 66 years since the Miller Urey experiment. This is the one place I disagree with him. I respectfully disagree with him because I'll tell you that with every given year, the complexity of life and the mechanisms within a cell. I work in medicine, guys. Trust me, every year with all of the medicines and everything else that comes out, I will tell you, we don't understand half of what goes on inside of one single cell. So the difference between 1952 when Miller and Urey did their experiment and today is every single year life gets more complex, and we're farther and farther and farther away from understanding how God did this. So when we go back to our argument about fine-tuning being the result of necessity, chance, or design, when you look at life, even life in its simplest form, in a single cell organism like an amoeba or a mycoplasma bacteria, the reality is they are not the result of chance or necessity. They're the result of design, and they're the result of God designing them. Anybody who looks at that data, at the data that it takes to build one living cell, and says that came about by chance, they have more faith than any believer I have ever met. Their faith is simply in something that is illogical. That's the difference between them and us. And at that, I'll answer your question. I'm going to repeat it just so they can hear it for the video. He says, well, why do they still teach Darwinism in school? So Darwinism, first thing is, Darwinism actually comes next, right? So Darwin actually didn't really necessarily talk much about the origin of life. He kind of used his starting point as life and then went from there, okay? Now, along those lines, at our last one to wrap up the teleological argument, when we talk about creationism versus Darwinism, we'll talk more about this. But the bottom line is that, remember how we talked about presuppositions? And that's the lenses through which you look at everything? That's the presupposition of atheists, is that Darwinism is fact. I am here to tell you Darwinism is not fact. It is a hypothesis. But the problem is that the academy, by and large, is atheist. That's why Darwinism is still taught in our schools. We'll get into it a lot more in the next session, but the reality is too is that what even Darwin saw as being evidence of evolution, it turns out that information was already there, right? You hear a lot about his Darwin's finches, okay? And the changing of the beaks. He was right. The beaks change over time. But guess what? That information was already there. It's just expressed. There is natural selection. There's no doubt about that. I don't think anybody in their right mind would disagree with natural selection, right? As an example, there are albino deer. How many of them do you see? Not too many. Why? Pretty easy to spot them. And in South Carolina, pretty easy to shoot them, right? Versus, the kind of typical gray-brown deer, pretty hard to see. I mean, you could be looking at the woods. The deer who's standing right there, you may not see it depending on how dense that woods are. But if the deer is white, that white deer ain't gonna live very long around here, right? So natural selection does exist, okay? But the information for those things is already there. Okay, perfect example. They like to point to these moths that lived in London. The moths, the vast majority of the moths originally were gray. But during the time when coal became the main mechanism of heat and power and all that kind of stuff, in London, the buildings by and large were covered in black soot from the coal burning, right? Well, all the gray moths went away. They were all black. Well, it turns out that's because the black moths were always there. But in the past, before coal started being burned, the buildings were made out of gray stone. So guess what birds couldn't see? A moth on gray stone, because the moth was gray. But what could they see? The black moth on the gray stone. So the birds would eat the black ones, the gray ones would survive. When the coal was being burned and they had all the soot on the building, guess what? All the gray ones now could be seen on the buildings. The birds were able to eat the gray moths, the black moths survived. When they cleaned up London, guess what happened? You started getting a mix of gray and black moths again. The information already exists. There's never been anything to show that there is any added information in any mutation of DNA. In fact, what does the vast majority of mutation of DNA do? You know this. How do you get cancer? You mutate the DNA. What happens? Person dies. Most of the time, it's even simpler than that. You mutate the DNA, the cell dies, right? So the funny thing is, the science shows that the vast majority of mutations kill the organism, but yet somehow we're supposed to believe that that then brings about some advantageous change in the organism that ultimately makes a new species. That's the real problem I have with Darwinism, is not that there is what's called microevolution, which means minor changes within a species, right? That's very clear. That happens.
But never recorded anywhere that we know of one species
To the next. None.
None.
In fact, there's less support for that now than when Darwin first came up with the theory. Far less. So much so that many geneticists and Darwinians actually have changed their terminology into different terminology because they realize there's such a problem with the way that the mechanism was originally proposed. You'll hear it called neo-Darwinism, meaning new.
We hope that you enjoyed the content of our video today. If you did, make sure to give us a thumbs up and share this content. Also, don't forget to hit the subscribe button and hit the bell so that you are alerted to any new content that we post on our channel. Please remember that all of our video content is completely free of charge and can be reposted, shared, and embedded. You can also find us on Facebook at facebook.com/armorofgodapologetics with an S. Thank you for watching and have a blessed day.